In many of the thermodynamic problems you will be given, you unfortunately will not be given the exact entry in a table. So what I mean by that is maybe you'll be asked to figure out the pressure if my temperature is 57 degrees, or my specific volume if my temperature is 111 degrees. And we don't have the entries for every single temperature. And what we have to do, if this is the case, is we have to interpolate between the entries that we do have. Now, the assumption we are going to make is that between every entry, the change in the values is small enough to be considered linear. So if I go from, let's say I want to figure out, what is my pressure at 57 degrees, and I'm using the water. I'm using water, so this is table A2, so I'm using my temperature. But going back to the interpolation, if these represent my two entries, over here I have temperature is equal to 60 T2, because I want to go, the closest entries I have are 55 and 60, and T1 is equal to 55. Now, P1 is going to be 0.1576, and P2 is going to be this 0.1994. Now, these are already the entries I have in my table. What I don't know is my pressure at temperature is equal to 57 degrees. Now, the way I solve the interpolation problems is I set up a ratio. So I say, okay, let's take this line segment right here. The slope of this line segment is going to be P minus P1 over T minus T1 is equal to the slope of this entire line segment. So P2 minus P1 over T2 minus T1. Now I just put my values in. I don't know what P is, but I do know what P1 is. So I have P minus 0.1576 over T, which is 57, minus 55. This is equal to P2, so 0.1994 minus 0.1576 over T2 minus T1, so 60 minus 55. All right, now I can just compute this. I can say, all right, 0.1994 minus 0.1576 divided by, this is 5, and this is going to be multiplied by this 57 minus 55, or 2. And then we're going to add plus 0.1576, and I'm going to get my pressure is equal to 0.17432 bar. Now, a way to check this, is this right? Well, we take our pressure and we just sort of eyeball between these two numbers. Yeah, 0.17432 is between my two numbers, so it's reasonable. This is a reasonable number, reasonable answer. The other thing that you should just sort of check is, if you set it up this way, these two numbers are going to be the same. So if those aren't the same, chances are you've done something wrong, or maybe you've written one of the properties wrong. I'm guilty of that sometimes. And the other thing you should know is it doesn't matter which is on the top and which is on the bottom, but you can have the unknown be at the bottom if you want. It will still solve because it's an equation with one unknown. There is a special case. If you are given what is the pressure at, what's this, at halfway, so 62.5, what you can actually do, so at 62.5, if it's the midpoint, you can actually just take the average. So if you have the midpoint, just take the average of the two entries that you do have. So it would be, I said 62.5, so 0.1994 plus 0.2503 divided by 2. And you would get this is equal to 0.22485 bar. Again, let's check this. Yep, that number is in between. It's actually at the middle, but it's a good habit to get into to check your interpolated values. So hopefully this gives you an idea of how you can interpolate between any two properties that you have when you're given a problem that doesn't align exactly with a thermodynamic table. And again, it really doesn't matter what properties you're using. You're setting up this idea of this linear change, so it's just the linear interpolation between any two values that you have.